Hi, my name is Stuart Wienig, and this video is an overview of SNMP trap processing by CA NetVoyant. My blog over at stuart.wienig.com has tips, tricks, and some best practices about all the products in the NetQS suite, including NetVoyant. I currently serve as the Communications Officer for the CA Infrastructure Management Global User Community. If you've been to the community, you've probably seen my name all over the place. I've been working with all the NetQS products since 2006, doing anything and everything. I've done installations at over 200 different customer sites with all of the products, and now I'm even starting to branch into some of the new products that CA is adding, like Infrastructure Management 2.0, CA Performance Center, NIMSoft, and others. So let's talk a little bit about what SNMP traps are and how NetVoyant processes them. Now, SNMP traps are messages sent out by a device to a network management system like NetVoyant. They're unidirectional in that they only come from the device, and like SNMP polling, they're connectionless using UDP 162. Now, a device must be configured to send traps to NetVoyant. Just having NetVoyant installed on your network is not going to guarantee that you're going to see any traps in NetVoyant. You'll have to go to the device, configure NetVoyant's IP address as one of the trap receivers. Now, NetVoyant, upon receiving traps, follows a fairly simple workflow to determine how to handle the traps. Upon receiving the trap, NetVoyant looks through its trap handler definitions to see if there's a specific handler for that type of trap. Now, if there's no match, a new alarm is opened with some default parameters. Now, if there is a match, NetVoyant checks to see if the trap matches the event filter or the clear filter within the trap handler definition. These filters determine whether NetVoyant should clear an existing event or open a new event or update an existing event. Now, if the clear filter matches, NetVoyant finds the existing event, one that should have already been opened by a previous trap, and closes it. However, if the event filter matches, NetVoyant determines then if there's an existing open event. Now, if so, NetVoyant updates the event parameters with the updated information from the trap, like an updated sysuptime or an updated status code or whatever. Now, if no open event exists for the sending device for the attribute described in the trap, NetVoyant will create a new event. So trap events will have the severity, category, and message defined by the trap handler. That's part of what goes into the trap handler. Now, if no trap handler exists for a particular trap type, NetVoyant just assigns generic description and a severity of minor to that alarm that it opens up. Here's a list of the default trap handlers defined in NetVoyant out of the box. As you can see, each trap handler has the ability to specify what conditions determine when to open an event and what conditions to close an event. Now, if no clear filter is specified, actually what happens is NetVoyant will never close the alarm automatically. You'll have to do it manually. Now, you can add a trap handler simply by going to Traps on the Config tab. Click the Add button, you're good to go. Now, you can use the out-of-the-box trap handlers as templates. One of the cool things about the NetVoyant GUI is you can actually open up one of the existing trap handlers and then click the Add button and have the two dialog boxes right next to each other. One example I should explain is the frame relay circuit status trap handler. This looks for a trap with trap type RFC 1315_MIB.FR DLCI status change, frame relay DLCI status change. In addition to looking for a trap of that type, NetVoyant also looks for a specific value in a specific binding in order to match the trap handler. In this case, it looks for a value other than 2 in the FR circuit state binding to open the alarm, and a value of 2 in that same binding to close the alarm. Because the thing is, frame relay circuits send out the same kind of trap whether or not it's up or down. It's the FR circuit state binding that indicates whether or not it's open or up or down, and closing or up or down. So this has been my presentation on trap processing in CA NetVoyant. I hope this video has been helpful. Subscribe to my blog, stuart.wienig.com, for more videos to come in the future, and thanks. Have a great day.